Welcome back, student. Today we're going to get this 300ER to its home in Istanbul. There will be no passengers and no luggage, and we'll land on the new Istanbul International Lima Tango Foxtrot Mike. Do the walk around and I'll see you up there. This is a new aircraft, so there should be no problems.
Good to know. The inboard aileron looks okay. That little flap sits behind the engine exhaust and is commanded by the fly-by-wire to help with rolling the aircraft. On takeoff, it's unloaded of hydraulic pressure, so the thrust of the engine will push it up. In normal flight, it helps the ailerons and the roll spoilers roll the aircraft around. Brakes look new. Tail dragger new.
So, let's bring this baby to life.
Got it. Such a simple overhead. Everything is automatic, just like in the Airbus. Even more so if I consider the hydraulic and the fuel systems alone. IFE and seats powers the in-flight entertainment and the USB power outlets. Utility powers the galley services and lighting. The window heat can be powered. It's automatic, so there's no danger of overheat. It also obeys load shedding logic. I'll call the refueling truck. We'll need about 17 tons block.
Please don't load aircraft until the fuel truck arrives and ask to do it.
Waiting for the units to get through the bit. As we got a bit of time, I'll let you know what I learned about the thrust levers. The engines are full FADEC driven, so we have a very smart auto-throttle that makes engine management a joy. Unlike the Airbus, which uses throttle detents for auto-throttle control, the 777 uses moving levers, while actual auto-throttle mode is controlled by the MCP.
Connected.
The levers are moved by an electric motor via friction clutches. Whenever the pilot wants control, they can overpower the clutches and move the levers. Each monster on the wing can produce over 52 tons of thrust on takeoff. That's 104 tons of force pushing you down the runway.
Have you understood the difference between a FADEC and an electronic engine control, EEC?
I think I got it. The FADEC is like the operating system of an EEC.
Great. That is exactly right. The FADEC is the software taking care of a hardware setup. The EEC is not just a computer watching for engine parameters. It's actually part of the engine. It's like one of its valves or pipes. There is no operation without the EEC, there is no bypassing it. In this sense, the hardware is the whole engine while the OS is the FADEC.
ADIRU goes on. I can set up the FMC. The Air Data Inertial Reference Unit is one of those systems that make you stand in awe at how far aviation has come in just 100 years or so. The architecture of the ADIRU puts the Air Data Computer and the Inertial Reference Unit into one single unit. It uses 6 laser gyroscopes and 6 accelerometers to provide triple redundant processing. The navigation precision it achieves is 0.01 nautical miles, and everything is automatic. By using the multi-mode receiver concept, it automatically switches navigation sources to add in the best precision required in the current mode. When the pilot selects an ILS frequency or an RNP approach, the system on its own selects the appropriate sensors to process the signals and put that info on the PFDs and the autopilot flight director system. It is amazing. I'll take the route from the servers. Really, the automation level on the 777 makes the A320 look like a golden era airliner. Loading the route. The trip should take 49 minutes, so it's a short one.
Yes. We have to go to Istanbul to get type rated for this big boy. Turkish operates quite a large Boeing fleet. From Istanbul we can operate long flights to the Maldives or Thailand as they do in real life.
The cruise part takes us from Dinro to Rixen via N616 Airway. Towards the east, they don't use free route airspace as they do in most of Eastern Europe. Free route airspace means if you have to cross an FIR, you can choose an entry point and an exit point and fly straight between those points. This shortens flight distances but puts a bit of stress on the ATC and slot timings. We'll take the Dinro 5 Bravo departure from Constanza and arrive via the Rixen 1 Alpha on 35 right at Istanbul. I'll take the LNAV RNAV approach. Istanbul is huge. It has so many arrivals and approaches that maybe it's better to request visual when seeing the airport. It also sits north of the big city of Istanbul, and there are many airports servicing the area, which adds up to a lot of restrictions. So approaches are very long. $185 tons takeoff weight. That is so light.
What is the minimum fuel temp value on the Perfinit page?
That is the minimum fuel temperature allowed for safe operations. In the past, there have been a few incidents and a hull loss accident where the fuel temperature got so low that it switched state into a wax. And when the approach called for a level off and higher engine regimes, the engines were starved and flamed out. This left fuel tank sensor checks that temperature in real time. If it gets close to it, an ACAS message is displayed and you have to descend to warmer altitudes or increase Mach number to increase skin temperature. Now, the feeding problem with low temperature fuel was solved by driving the fuel around an oil heat exchanger, so it should not be a problem anymore. However, having a monitor for the wing tank fuel viscosity is a welcome safety feature, especially for those 16-hour flights between Dubai and LA. Because of the light weight, we're going to derate to takeoff too, taking off 20% off the max thrust. And we're also going to use a flex temperature of 57 Celsius. This gives us a takeoff N1 of 89.9%, which means that the huge fan rotates at 2,117 RPM. This puts the fan tip at almost Mach 1.1. ADIRU's still aligning. 2 minutes and a half left. This features fully integrated checklists. And because of the automation, the checklists revert back to actual flows even more than in the case of Airbus. Of course, I did so much before getting to the pre-flight checklist, but it was so natural that the 4 checklist items seemed the most important and forgettable items. Basically, every flow means going from the wall to the overhead, the MCP, and down to the pedestal, and setting everything in order for the current phase of flight.
Constanta Tower, Turkish 3048 Heavy, Boeing 777-300ER with information Papa, Cargo 1 request IFR clearance to Istanbul Airport.
Turkish 3048 Heavy, Constanta Tower, cleared to Istanbul Airport via DINRO 5 Bravo departure, runway 36, climb via SID to flight level 110, squawk 1733.
Cleared to Istanbul Airport via DINRO 5 Bravo departure, runway 36, climb via SID to flight level 110, squawk 1733, Turkish 3048 Heavy.
Turkish 3048 Heavy, read back correct. Call me back when ready for pushback or engine start.
Wilco Turkish 3048 Heavy.
Wait, I cannot set the radio volumes?
Yes, given the manufacturer, I consider you're doing something wrong. But then again, those are the correct knobs.
But on all other add-ons, you could set the volume from within the aircraft. Moving on. Heading is 047 on all. Altimeter 1022, consistent. Well, the ADIRU is a single unit outputting 3 values for all flight parameters. It uses uncertainty propagation, so it's hard to see a difference on identical baro settings. Closing doors, getting ready for the pull and engine start. V2 on MCP. Flight directors go on and VNAV check. APU goes on. We need its bleed air for start. We could also use the air start unit. MCP, V2 at 145, heading 360, altitude 110. V1 is 129, we'll rotate at 135, V2 is 145. Trim is 525 for takeoff, but first I need hydraulics to set trim. Before pressurizing hydraulics, I'll check that no ground personnel is in danger. First, left electric demand pump goes auto. This powers nose wheel steering, left main gear brakes, and left flight controls. The right demand pump is next. This powers main gear brakes and right flight controls. Next are the C1 and C2 electrical pumps. These power the high flow volume systems like the landing gear extension, main gear steering, and flaps. Last but not least, there are also 2 air-driven pumps to assist or take over high demands in the systems. 525 set on the trim.
Turkish 3048 Heavy request startup.
Turkish 3048 Heavy, engine start approved, call when ready for taxi.
Wilco engine start approved, Turkish 3048 Heavy.
Hello, Captain. We are ready for pushback.
Clearly, it is not a good idea to start the engines here. I'll pull the aircraft a bit forward before waking the monsters.
Departure checks completed. Bypass pin inserted. Locking gear. Release parking brakes, please. Commencing push. All engines clear. Start at will.
Clear to start. Fuel pumps go on. Starting engine 2. Bleed air from the APU goes into the ATS, the air turbine starter. This little unit turns the accessory box, which in turn rotates the N2 spool. The exhaust thus does not enter the turbine and never affects the engine, except for turning the N2 spool to about 20% RPM. Using a lightweight reductor on a fast spinning starter will leverage huge torque on massive engines like the GE90. The ATS can spin at 40,000 RPM on APU bleed air alone. Starting engine 1. . Good start.
Turkish 3048 Heavy, taxi for departure.
Cockpit to ground. We have a good engine.
Turkish 3048 Heavy, taxi to holding point Bravo, runway 36 via Bravo, Hotel Alpha.
Taxi to holding point Bravo, runway 36 via Bravo, Hotel Alpha, Turkish 3048 Heavy.
Bravo. No. We'll go to Alpha Holding. I cannot put Bravo in the performance calculator. Whenever we're a little bit in front of Alpha, they give us Bravo.
Tow truck disconnected. Bypass pin removed. Left is clear, right is clear.
Flight controls check. Full up. Full down. Neutral. Full left. Full right. Neutral. Rudder left. Rudder right. Neutral and correct. Flaps 5 set.
Turkish 3048 Heavy, ready for departure, runway 36.
Turkish 3048 Heavy, Constanta Tower, wind 010 degrees 10 knots, runway 36 cleared for takeoff.
Runway 36 cleared for takeoff, Turkish 3048 Heavy.
50% synchronized. Takeoff. Hold mode engaged. Levers are free. Oh wow, that acceleration was insane.
Positive rate of climb.
Turkish 3048 Heavy, contact Constanta departure 122.905.
Contact Constanta departure 122.905, Turkish 3048 Heavy. Constanta, Turkish 3048 Heavy, passing 3,200 feet, climbing to flight level 110.
Turkish 3048 Heavy, Constanta departure, identified, climb flight level 160.
Climb flight level 160, Turkish 3048 Heavy.
All aircraft be advised information Quebec now current, QNH 1022. Turkish 3048 Heavy, contact Bucharest radar 121.18, bye-bye.
Center on 121.18, Turkish 3048 Heavy. Bucharest radar, Turkish 3048 Heavy, passing flight level 140, climbing to flight level 160, direct in row.
Turkish 3048 Heavy, Bucharest radar, good day, identified, climb flight level 330.
Climb flight level 330, Turkish 3048 Heavy.
That climb was way too fast for me.
Wisco 7 Kilo Golf, descend via start to flight level 050.
Descend via start to flight level 050, Wisco 7 Kilo Golf.
Flight level 330.
Wisco 7 Kilo Golf, contact Constanta approach 122.905.
Contact Constanta approach 122.905, Wisco 7 Kilo Golf.
First Eagle 8347, contact Sophia Control 132.905.
Contact Sophia Control 132.905, First Eagle 8347.
510 feet is the decision altitude for the LNAV VNAV approach.
Bucharest radar, Center to Romeo Juliet, flight level 340. Center to Romeo Juliet, Bucharest radar identified. Turkish 3048 Heavy, contact Sofia Control 132.905.
Contact Sofia Control 132.905, Turkish 3048 Heavy. Sofia Control, Turkish 3048 Heavy, passing flight level 269er, climbing to flight level 330.
Turkish 3048 Heavy, Sofia Control identified.
Checking the approach for backtracking.
First Eagle 8347, contact Sofia Control 134.7.
Contact Sophia Control 134.7, First Eagle 8347, have a good day.
Turkish 3048 Heavy, cleared Brixton 1 Alpha arrival, runway 35 right.
Setting up landing data. We'll land at 11.2 tons of fuel, meaning 179.8 tons gross.
Turkish 3048 Heavy, cleared Brixton 1 Alpha arrival, runway 35 right.
Gives us a ref speed of 126 knots.
Turkish 3048 Heavy, Sofia control.
Turkish 3048 Heavy, request approach change.
Turkish 3048 Heavy, you've not yet started your descent, unable. Turkish 3048 Heavy, report ready for descent.
Wilco Turkish 3048 Heavy.
Turkish 3048 Heavy, contact Sofia control 134.7.
Center on 134.7, Turkish 3048 Heavy. Sofia control, Turkish 3048 Heavy, flight level 330.
Turkish 3048 Heavy, Sofia control identified.
Turkish 3048 Heavy approaching our top of descent, ready for lower.
Turkish 3048 Heavy, descend to flight level 230.
Descend to flight level 230, Turkish 3048 Heavy.
Starting our descent.
Turkish 3048 Heavy, request approach change.
Turkish 3048 Heavy, confirm new approach ILS X-ray approach runway 35 right.
Negative, Turkish 3048 Heavy. Turkish 3048 Heavy, request approach change.
Turkish 3048 Heavy, confirm new approach ILS X-ray approach runway 35 right.
Negative, Turkish 3048 Heavy.
Okay, the VNAV algorithm is descending too fast. I'll hold it to 1,000 feet per minute until we catch the profile. requesting the descent wind profile. Still way under the arrival profile. I'll go 500 feet per minute. Finally, vertical profile is coming into intercept area.
Turkish 3048 Heavy, descend flight level 160.
Descend flight level 160, Turkish 3048 Heavy.
160. The three hydraulic systems look okay. The left and right ones are powered by the engine-driven pumps, while the center one is powered by two electrical pumps in low demand, or two pneumatic pumps for high-demand regimes.
Turkish 3048 Heavy, descend via star to 5,000 feet, QNH1018.
Descend via star to 5,000 feet, QNH1018, Turkish 3048 Heavy.
Turkish 3048 Heavy, contact Ankara Control 119.3.
Contact Ankara Control 119.3, Turkish 3048 Heavy.
Sunturk 1982, anchor control, identified, climb flight level 310.
Climb flight level 310, Sunturk 1982.
Ankara Control, Turkish 3048 Heavy, good day, passing flight level 224, descending to 5,000 feet.
Turkish 3048 Heavy, Ankara Control, identified.
Ankara Control, Iran F718 Heavy, passing flight level 160, climbing to flight level 190.
Iran F718 Heavy, Ankara Control, identified, climb flight level 390.
Climb flight level 390, Iran F718 Heavy.
Turkish 3048 Heavy, reduce speed 250 knots.
Reduce speed 250 knots, Turkish 3048 Heavy.
They want us at 250. There's a lot of traffic around Istanbul. Before going into the busier environment of the approach, I want to tell you a bit about the auto-throttle logic. So, the levers are moving with the auto-throttle demand. However, the hold status on the FMA means that the clutches have disengaged, and you can easily set thrust by moving the levers without fighting off the clutch mechanism, like I did just now. Nevertheless, even in hold, the auto-throttle logic monitors speed, and if you break the speed allowances, it will revert to idle or speed. It's mainly a turbulence protection system. If on your way down you go through a large wind direction or speed change or even turbulence, speed mode would try to hit speed perfectly, revving up and down those big engines like something is very wrong. There's no point in it doing that, and it will wait for a more average tendency of speed before acting.
Turkish 3048 Heavy, resume normal speed.
Resume normal speed, Turkish 3048 Heavy.
And just like in the Airbus, speed is given back to the airplane.
Anchor Control, Turkish 8 Romeo Juliet, good day, passing flight level 160, climbing to flight level 190, direct Alpha.
Turkish 8 Romeo Juliet, Ankara Control, identified, climb flight level 390.
Climb flight level 390, Turkish 8 Romeo Juliet.
Iran 718 Heavy, contact Ankara Control 136.6.
center on 136.6 Serena 718 heavy.
Saitek 1982, contact Ankara Control 136.6.
Contact Ankara Control 136.6, Saitek 1982.
Turkish 1272, descend via start to 4,000 feet, QNH 1018.
Descend via start to 4,000 feet, QNH 1018, Turkish 1272.
Ankara Control, Turkish 9 Golf Yankee, passing flight level 140, climbing to flight level 170.
Turkish 9 Golf Yankee, Ankara Control, identified, climb flight level 340.
Climb flight level 340, Turkish 9 Golf Yankee.
Turkish 8 Romeo Juliet, contact Ankara Control 136.6.
Center on 136.6, Turkish 8 Romeo Juliet.
Turkish 3048 Heavy, reduce speed 230 knots.
Reduce speed 230 knots, Turkish 3048 Heavy.
Turkish 3048 Heavy, resume normal speed.
Resume normal speed, Turkish 3048 Heavy.
Turkish 1272, contact Yesukoi approach 118.905.
Contact Yesukoi approach 118.905, Turkish 1272.
Turkish 3048 Heavy, contact Yesukoi approach 119.35.
Contact Yesukoi approach 119.35, Turkish 3048 Heavy. Yesukoi approach, Turkish 3048 Heavy, passing 10,100 feet, descending to 5,000 feet with information Delta.
Turkish 3048 Heavy, yes Sukhoi approach, 2NH1018, expect the ILS Zulu approach, runway 35 right with the Imran transition.
2NH1018, expect the ILS Zulu approach, runway 35 right with the Imran transition, Turkish 3048 Heavy.
Well, we lied. We're going to do the RNP approach to 35 right.
Turkish 2 November Papa Heavy, contact Istanbul Tower 130.8, have a good day.
Contact Tower 130.8, Turkish 2 November Papa Heavy, good day.
Turkish 7 Bravo Mike, descend via start to 5,000 feet, QNH1018.
Descend via start to 5,000 feet, QNH1018, Turkish 7 Bravo Mike.
Turkish 3048 Heavy, cleared direct Imran, cross Imran at or above 5,000 feet, cleared ILS Zulu approach runway 35 right.
Cleared direct Imran, cross Imran at or above 5,000 feet, cleared ILS Zulu approach runway 35 right, Turkish 3048 Heavy.
Turkish 84 Whiskey, descend via start to 5,000 feet, QNH1018.
Descend via start to 5,000 feet, QNH1018, Turkish 84 Whiskey.
Turkish 84 Whiskey, maintain 5,000 feet until established, clear ILS Zulu approach runway 35 right.
Maintain 5,000 feet until established, cleared ILS Zulu approach runway 35 right, Turkish 84 Whiskey.
Turkish 84 Whiskey, contact Istanbul Tower 130.8, good day.
Contact Tower 130.8, Turkish 84 Whiskey, good day.
Turkish 3048 heavy, minimum approach speed.
Minimum approach speed, Turkish 3048 heavy.
They are swamped. Minimum approach speed in clean config is up speed. However, I can go halfway between up and amber to help them more. I can see the traffic on the approach, but I think they're exaggerating a bit with this separation. Oops, this was more muscle memory than anything else. On a RNP approach, there is no need to engage the approach mode. The system is already in LNAV VNAV, and the ADIRU will switch the necessary sensors on when getting at the FAF.
Turkish 7 Lima X-ray, contact Istanbul Tower 130.8, bye-bye.
Over to Tower 130.8, Turkish 7 Lima X-ray, bye-bye.
Turkish 7 Bravo Mike, cleared direct static, cross static at or above 5,000 feet, cleared ILS Zulu, approach runway 35 right.
Clear direct static, cross static at or above 5,000 feet, cleared ILS Zulu, approach runway 35 right, Turkish 7 Bravo Mike.
Turkish 3048 heavy on final approach 35 right.
Turkish 3048 heavy, roger.
Before starting the final descent, I have to set an altitude lower than the level segment. When the aircraft gets lower than 500 feet below the missed approach altitude, I can set the missed approach altitude and the aircraft will continue the descent on the RNP glide slope. That is 5,000 feet here.
Turkish 3048 heavy, contact Istanbul Tower 130.8.
Contact Tower 130.8, Turkish 3048 heavy. Istanbul Tower, Turkish 3048 heavy, ILS Zulu, approach runway 35 right.
Turkish 3048 heavy, Istanbul Tower, continue.
Roger, Turkish 3048 heavy.
Turkish 84 Whiskey, exit right at Charlie 9er.
Exit right at Charlie 9er, Turkish 84 Whiskey.
Lima X-ray, wind 040 degrees, 15 knots, runway 35 right, clear to land.
Runway 35 right, clear to land, 37 Lima X-ray.
7 Lima X-ray landing in front of us.
Lima X-ray, exit right at Charlie 8.
Exit right at Charlie 8, 37 Lima X-ray.
Turkish 3048 heavy, wind 040 degrees, 15 knots, runway 35 right, clear to land.
Runway 35 right, clear to land, Turkish 3048 heavy.
There we go. Cleared to land.
Approaching minimums. Minimums. $50. 20. 10.
Yeah, the spoilers don't deploy if I use the FCS to put them in arm. It's a simulator quirk. In any case, we're super light. Reversers and auto brake will take care of energy dissipation.
Turkish 3048 heavy, exit right at Charlie 8.
Exit right at Charlie 8, Turkish 3048 heavy.
Clean up.
Turkish 3048 Heavy, contact ground 122.6, have a good day.
Ground 122.6, Turkish 3048 Heavy.